Okay, welcome student. Now we'll be discussing on the part 6 of this chapter 1 on real numbers. Okay, now before going to start with this, let us remind ourselves regarding this rational number which I've given you here as a note, that a rational number of the form p by q, where q does not equal 0, is said to have a terminating decimal representation if the factor of q, which is denominator, are in the form 2m multiply 5n, where m and n are non-negative integers. Okay, and if this rational number p by q is said to have a non-terminating decimal if the factors of q are not in the form 2m multiply 5n, where m and n are the same thing, non-negative integers, provided that the rational numbers are in its lowest form. Okay, now p is the numerator, q is the denominator. Okay, we have to find the factor of q's, the prime factorization. We have to do the prime factorization. In the previous class we have discussed about finding the prime factorization. I think by this time you will be able to do it, to find it, the prime factorization of the denominator. And if you find that the factor of q are in the form 2m multiply 5n, then the given rational number are said to have a terminating decimal. Otherwise, if they are not having in this form, it will represent a non-terminating decimal representation. Clear? And here in note number 2, the decimal representation of a rational number can be terminating. First condition, it can be a terminating decimal representation, or it can be a non-terminating, but it should be a repeating decimal representation. If the decimal representation is non-terminating and non-repeating, that means it will be an irrational number. Here I have given you as in the note 2 that if the representation is non-terminating and non-repeating, it will not be a rational number, but it will be irrational numbers. Okay, in a rational representation you will always find two cases. One case is that it will be terminating, and if it's not terminating, it should be repeating. Okay, repeating mean like if you divide 10 by 3, 10 by 3 is a rational number. Okay, if you divide 10 by 3, what you will get? 3, 3, 3, 3, 3, so many 3, isn't it? It's non-terminating, it is not ending, but it go on repeating 3, 3, 3, 3 so many times. If you find that the decimal representation of a number is non-terminating and non-repeating, suppose if you find 3.1257346, mean any random number, then it will be the representation of an irrational numbers. Okay, I think this will be clear with you. What is irrational number and how will be the expression of irrational number in decimal representation. Clear? Now we move ahead with the problem, the first problem from here. If a by b is a rational number where b does not equal to 0 on its lowest form, what is the condition on b so that the decimal representation of a by b is terminating? Okay, in this note we have just discussed that if this given rational number is in lowest form, the condition that the decimal representation of this rational number is tempting is that the denominator should be in the form 2m multiply 5n. The condition of B so that the decimal representation is tempting will be in this form 2m multiply 5n, where m and n are non-negative integers. Okay, number 2, that means to have a tempting decimal representation, you should always, the denominator should always have in this form 2m multiply 5n. M and n can be non-negative integers, that means starting from 0, 1, 2, 3, 4, 5, okay, starting from 0. And one thing I want to discuss with you, that if I write 2 power 1, it is 2. 2 power 2 is 4. 2 power 3 is 8, isn't it? You know all this thing. But if I write 2 power 0, what it is? 2 to power 0, you should remember that is always 1. If I write any number to the power 0, should always be equal to 1. Clear? Now going to the next, number 2, it is correct to say that 343 divided by 2 multiply 7 multiply 5 square has a non-tempting and repeating decimal representation. Okay, now what you will do, you will check whether this given rational number is in the lowest term or not. Now we have 343 by 2 multiply 7 multiply 5 square. Now 7 to, you can cancel with 343 going with 49. Okay, 49 by 2 multiply 5 square. Okay, now 49 is whatever it is, we don't need to bother about the numerator. Now look for the denominator. Denominator is having 2 to the power 1, 5 to the power 2, isn't it? 2 to the power 1, 5 to the power 2. That means it's having in the form 2m multiply 5n. That means what should be the representation? It should be a terminating decimal representation, isn't it? It should be a terminating decimal representation. Here the denominator is in this form 2m 5n, where m is 2 to the power 1, 5 to the power 2, where m is 1 and n is 2, which represent a terminating decimal representation. Hence we can say that no, is not correct to say that the given representation is a non-terminating, because why? It is not in the lowest form. Now here you just see this given expression 343,275 square. Now if you look on this denominator here, it would have, it doesn't have 2m multiply 5n, because 7 also is here as one of the factors, isn't it? Just by looking at this, we can say that yes, it is a non-terminating and repeating decimal representation. Because why? Because it's not having in the form 2m 5n because of this 7 here. But if you take the lowest form of this expression, we are getting 49 by 2 multiply 5 square, which is this in this lowest form. What is this denominator having? In which form is having? It's having in 2m multiply 5n, which is a terminating. Okay, thus we can say that is not is a terminating decimal representation. Hence it's not correct to say that, because why? The given representation is not in the lowest form. Now the next, number 3, without performing the long division, state whether the following rational number will have a terminating decimal representation or not. You have to check whether is having a terminating or not. This means we have to take the lowest form of this given rational number and then find out the denominator whether it's having in the form 2m multiply 5n or not. Okay, now the first one is 125 by 44. The factor of 125 are 5 multiply 5 multiply 5. 5 multiply 5, 25. 25 multiply 5 is 125. And 44 is 2 multiply 2 multiply 11. Okay, now denominator is having 5q and numerator is having 5q, and denominator is 2 square multiply 11. Okay, we don't need to bother about the numerator. We have to check for this denominator. Denominator is having 2m multiply 11. 2 square multiply 11. Okay, actually to have a term thing, it should be 2 multiply 5. Therefore, it's not having in this form 2m multiply 5n. Therefore, this given rational number is a non-terminating but repeating. Okay, hence the given rational number will have a non-terminating and repeating decimal representation. Okay, next number 2, 28 by 8. Okay, 28 we can write factor as 2, 2 and 7, whereas 8 as 2, 2 and 2. On cancelling here, 2, 2 cancel, we have 7 by 2. Okay, now 7 by 2 is it tempting or not? Is the denominator is having in the form 2m multiply 5n? Yes or no? The answer will be yes. Because why? Is having in this form because 2 is having the power 1, isn't it? Multiply with 5 to power 0. I've discussed from very beginning. 5, when you write 5 power 0, what is 5 power 0? 5 power 0 is 1. Now 2 power 1, which is 2. 2 multiply 1, it is 2 itself, isn't it? Therefore, the denominator is having in the form 2 power 1 multiply 5 power 0, where m is 1 and n is 0. That means this will be terminating. Clear? Again, let us check here. 5 power 0 is how much? 5 power 0 is 1. 2 power 1 is 2. 2 multiply 1, it is 2. This same denominator only, isn't it? Therefore, even though 5 is not here, but we can write as in the form 2 multiply 5, where the power of 5 is 0 and the power of 2 is 1. Now the next number, 129 by 2 square 5 power 7 and 7 to power 7. Now factorizing 129 will be 3 multiply 43. Okay, now there is no factor which we can cancel here. Therefore, just look at this denominator. The denominator should have 2m multiply 5n, but 7 is here, also here, isn't it? 7 is also here. That means this denominator does not have in the form of 2m multiply 5n. Then what we can say? That the decimal representation of this given rational number is non-terminating but repeating decimal representation. This rational number will have a non-terminating and repeating decimal representation. Why? Because it's not having in this form 2m multiply 5n. Clear? Next we go with the number 4. Find the write down the decimal expansion of the following rational number by writing their denominator in the form 2m multiply 5n, where m and n are non-negative integers. Okay, write down the decimal expansion of the following numbers and write down also the denominator in this form 2m multiply 5n. Okay, the first is 3 by 8. Now 3 by 8 you can write as 3 you can write as it is, because there is no more factor. And 8, the factor of 8 are 2, 2, 2, isn't it? 2, 2, 2. Now 2, 2, 2, 2 cubed multiply 5 to power 0. As we have discussed in the last problem, 5 power 0 is 1. Now 2 cubed, which is 8, 8 multiply 1 will be 8 itself, isn't it? Therefore, this denominator can be written in the form 2m multiply 5n, where m is 3 and n is 0. Which means that it will be a terminating decimal representation. And let us find the decimal expression of this, whether it is terminating or not. Okay, now 3 divided by 8. 8 you go with 0 is 0. Then you go decimal, you drop down 3. Then when you go decimal, it will be 30. 8 multiply 3 is 24. Then remainder with 6. Once you have gone with decimal, it will be, you will have to drop down 0. That is 60. 8, 7, 56. Then remainder 4. And then drop down 0, 40. 8, 5, 40. Mean the division ends here, isn't it? It means it terminates here at 40. This means the expansion of 3 by 8 is 0.375. Okay, next number 2. 7 by 80. 7 by 80. 80 you can find the factor of 80 as 2, 2, 2, 2 and 5. Mean 2 power 4 multiply 5. This you can just you can directly say that yes, is having in the form 2m multiply 5n, where m is 4 and the power of 5 here is 1. Okay, which represent a terminating decimal. Let us check by dividing whether it is terminating or not. Now 7 divided by 8. You go with 0 is 0. 80 multiply 0 is 0. Then you have 7. You go with decimal, it will become 70. Now 80 with 1 will be 80. Is bigger than the 70, isn't it? Therefore you go again with 0. It will be 0. Then you have 70. Drop down with 0 will be 700. Now 80 multiply how much is 700 or less than 700? 80 multiply with 8 is 8, 8, 64. That means 640. Remainder here is how much? 700 minus 640 is 60. Then when you go decimal, that 0 will always drop down here. 600. Now 8 with 7, 56. Mean 8 multiply 80, 80 multiply 7 will be 560. Then again 400. 40 will drop down, become 400. No, 40 will remaining and 0 will be dropping down, will come 400. Now 8 with how much is 8 with 540, isn't it? That means 8 with 540. 8 with 80 with 5 will be 400. This means the division will end here at 0.0875. Clear? The next is 14588 by 625. Now I've not shown you here how the factorization is being done, but the factorization is here. I've shown to you, and if you find the factor, you will get as 2 square multiply 7 multiply 521. 625, the factor of 625 is 5555. This means 5 to the power 4. Now there is no common term to be cancelled from numerator and denominator. That means it is already in the lowest form. Now check for the denominator. Is the denominator having in this form 2m multiply 5n? Yes, because you can write 2 as power 0. 2 power 0 is 1 and 5 to the power 4. The denominator is having in the form 2m 5 multiply 5n, where m is 0 and n is equal to 4, will represent a terminating decimal. Now let us check whether it is terminating or not. 14588 divided by 625. You go with 2. See the 3 digit 625 145. Now this divisor is bigger, therefore you take 4 digit the dividend you take with 4 digit. Now 606 with how much is 12? 6 with 2, 12. This means 2 multiply 6 to 5 will be 1250. Subtracting, you will be getting 208. Then you drop down 8. Then 625 multiply 3 is 1875. Then you will be remaining with 213. You go decimal, it will be 2130. You go with 3, it will be again 1875. Then remaining will be 255. Then you drop down 0, will be 2550. Then 625 you go with 4, will be 2500. Then we'll be getting 50 from here, and drop down 0 will be 500. Now 600 with how much will be this much? If you go 1 also will be 600, therefore you will go with 0, will be 0. Then you have 500, again drop down to 0, will be 5000. Now 625 multiply with how much to become this much? If you go with 8, will be 5000. That means the division will end here at 23.3408. Okay, it means it's terminate the long form division on dividing this 14588 by 625. It terminate at 23.3408. Clear? Now this is the end of the part 6. We shall discuss the next part on the next class. Okay, bye to all of you.